Hi there, guys. Well, welcome back. We're about to do 5B, and 5B is simply a discussion of sampling techniques, and there are 5 of these. This should be a pretty short video. So, there are 5 ways of making a sample which you need to know about. And so they are called SRS, simple random sampling, systematic sampling, stratified sampling, quota sampling, and convenience sampling at your convenience. Okay, there's a little investigation here as well, which I'm not going to go through, but you can look at that too. And there's a little comment box, and we'll look at question 2, and then we are done. We are up to 5B then. Just take me away. Right, so let's talk about these samples then. So there are different ways in which you can take a sample from your population. You know, maybe you want 100 people out of a population of 10,000. And you've got to think, as a statistician, as a mathematician, you've got to think, how are we going to choose those 100 people so as not to create any bias, you know, to create any particular leaning in our answers, you know, a more common answer than another, for example. So the classic way of doing this would just be to set up a simple random sample. So it says each member of the population has an equal chance of being selected. And a sample is chosen by drawing, for example, names out of a hat or assigning numbers to the population and using a random number generator. Right, okay. Well, it's difficult to make a random number generator, in fact. You know, because every time you load up that program, it starts at the same point again, you know, because it follows the same processes. So first of all, it's quite hard to make a random number generator, although, you know, I'm sure you can make things pretty random if you put some conditions on where to open the program up, for example. But okay, you get the idea that basically random means that everyone has an equal chance of being picked. There you go. You're gonna draw names from a hat if you like. Okay, and it says example to conduct a simple random sample to find the mean length of time spent doing homework. You might put the names of every student in the school into a hat and draw the names of 100 students to form a sample. Now you've got to think about what the pros and cons of this are doing. I mean, generally this is a really good method of sampling, but sometimes it can just be quite difficult to maybe access certain people. Maybe it's quite difficult to write down everyone's name in the entire school and put them in a hat. So, you know, although this is kind of ideal and theoretically really good, practically there might be some things which make this a relatively slow method or mean that you can't actually access some people. Okay, so there you go. There's the first one. Systematic sampling. Right, so here we go. We're talking about, here you list members of a population and select a sample according to a random starting point and a fixed interval. Okay, so what does this mean? Let's just take that one, in fact. Okay, so for example, okay, so for example, if you had a block of flats, like they were talking about in the previous section, and they're saying you want to interview people, you know, interview someone from a flat in each of the 100 flats, and there are, let's say there's 10 floors. And now you've got your list, your sampling list, which goes from 1 to 100. Okay, and you want to choose, say you choose the first, and then you choose the, actually let's go, let's choose the 10th, let's choose the 20th, let's choose the 30th, and so on until we get down to the 100th. So let's choose every 10th flat. Now it's possible that every 10th flat is in a particular corner position. Maybe it's in a great corner position that gets lots of sun. And, you know, so it might be, or maybe it's a bigger flat, or, you know, maybe there's something great about it, or maybe there's something terrible about it. But there's problems for systematic sampling in that there's a potential for you to get some kind of bias if something is turning up regularly on that list. Now, to be honest, if you're, coming up with your entire school list of maybe just names in alphabetical order, or maybe just, or maybe by year group, you've got maybe 1,000 students, and you take off every 10th student, for example, probably you're going to end up with a really good sample. And it's a really quick way as well of coming up with all of those, not random, but all of those people in your sample. Okay, so there you go. So systematic sampling is generally pretty good, probably in most cases as good as random sampling. However, it's not random, and there are odd cases where you could end up with the same bias being repeated. Okay, okay, so that's two of them, and now we've got stratified sampling. So stratified sampling says this involves data dividing the population into non-overlapping smaller groups known as strata. Now, really important, it says non-overlapping. Okay, so there's lots of ways in which you could divide up. Oh, what's going on here? There's lots of ways in which you can divide up. There you go. Your population. You could say, well, look at the school group. We've got year 7, 8, 9, 10. They're non-overlapping groups. Or you could say, well, actually, we've got male and female. Okay, and generally in school, that's a non-overlapping group as well. Okay, well, so there's lots of ways in which we can create strata, and we don't want these, whatever groups we choose, we don't want them to be overlapping. Okay, and then when the strata are formed based on the members' characteristics, then you choose a random sample from each strata and then put them together to form your sample. Okay, so so for example here, I mean, what they're saying here is they're saying, well, look, there's 4 different year groups. We want a sample of 100. Let's take 25 from each year group. So it's just saying I want each of these individual groups which we have in this population to be equally represented. I want to know what's the experience in year 7, what's the experience in year 8, what's the experience in year 9. And I'm interested in getting a good view of that experience, because I think, and as a mathematician or statistician, the person who's setting this sample up, the point is that we're pretty sure that we want to know what this subsection of the population thinks about the issue, or to get the values from that subsection. We think this is important in itself. Okay, now when we choose 25 students, we'll probably choose them at random. Okay, well, in fact, we're told, in fact, we should choose them at random. But okay, so that's stratified. But then there's also a little extension to that, is quota sampling, and that's pretty much the same, except for instead of us saying, well, we really want to know what's happening in year 7, what's happening in year 8 and year 9, we actually just want to know generally what's happening. And we know that, in fact, we have, half the number of students in year 7 as we do in year 8. So actually, to look at the general experience, we want to actually take twice as many students from year 8. So quota sampling is the same as stratified sampling, except for we need the right proportion from each of the stratas, as saying we want the same proportion in our sample as we have in the population. Okay, so again, for example, if we have 60% of the students in the school are female and 40% are male, then in the quota sampling, we need to take 60% female students. And again, we take those at random, ideally at least. Okay, and so finally, the 5th one here is convenience sampling. And this is saying this is the easiest method by which you can generate a sample. It says you select those members of the population who are most easily accessible or readily available. For example, if you're going to conduct a survey, and collect a sample to find the mean length of time doing homework, you might survey the students who are in the same class as you. That's kind of convenient. They're there. they're there that you can make the sample really quick, and this is a very quick way of doing some statistics. So there we go. It's just at your convenience, essentially. And obviously, this is the worst version of doing sampling. So we started off with something really good, simple random sampling, and we ended up with convenience sampling, which is a pretty poor way of doing things, because obviously the people in your class might be, if you're, a really outstanding group, might be the type of people who do more homework. I don't know. Okay. So there you go. There's an investigation, which I'm not going to go through. There's a little box here which says, provided the sample is a random sample, the mean of the sample means is approximately equal to the population mean. Okay, that's interesting. So we're talking about the mean of the sample means there. So that's the investigation. They're taking you through making means, many means from a population, and then they're taking the mean of the means, and they're saying the mean of the means, the mean of the sample means is approximately equal to the population mean. Well, often we've only got one sample mean, and the sample mean is the best that we can do to make an estimate for the population mean, and that would generally be considered to be an unbiased estimator for the population mean, and we'll talk about that in a bit. Okay, but this investigation led you to the idea that taking the mean of a set of sample means is approximately equal to the population mean. Okay. Now it says, therefore, the sample mean can be used as an estimator for the population mean. Okay, well, it's telling you that there. We'll talk a little bit later about unbiased estimates for means and standard deviations as well. Okay, so in example 2, it says, a researcher wishes to understand the target market for a new variant of Bluetooth headphones. It has been established that the target market falls into the following age categories or age ranges. So you can see the age ranges, and obviously we can see that age 16 to 25 represent a 58% share of this target market. Okay, now part A says, describe how you could use quota sampling to produce informed results on a sample of 200 people. So in other words, we want to make sure that we've got 58% of people are between 16 and 25. And seeing as we've got a sample of 200, all we need to do is double our percentages there. Okay, so that's pretty straightforward. Those are our numbers now. So we've got 116, 50, 24, and 10. Now, sometimes when you do this, you end up getting, decimals for the amounts of people, and you'll need to round up or round down. And then when you add together all of your rounded values, you sometimes find you don't have 200. So there are interesting examples where you have to make a call as a statistician to say, well, listen, this one is nearer to going up or something. So there we go. We're going to give one more to this group. So this is not necessarily an exact science all the time. Okay, now discuss the advantages and disadvantages of this technique. Well, I suppose the advantages are that the age categories are accurately represented in our sample, and especially if we consider that each of our age categories has possibly something different to say, or some different information to provide, then we really need to take into account those different sections into our whole strategy to make our marketing strategy, if you like. Okay, a disadvantage might be that maybe it's difficult to find enough people between 46 and 55, for example, in order to survey. So maybe there's practical considerations when we're going out and trying to find the right number of people for this sample, especially if we're trying to do that randomly. Okay, so let's see what they say. They say the advantages is this sampling process is quick, simple, and convenient. Okay, so I guess the idea of constructing the sample is quick, right? So then the disadvantages, as it says, in practice, it may be difficult to find the appropriate amount of people, and asking their ages may be a sensitive subject. Okay, I didn't think of that. So asking people's ages could be sensitive there. Okay, yeah. Okay, well, there we go. That's kind of done. I suppose with the disadvantages, we just need to think about practically how are we going to collect this now? How are we then are going to go forward and collect this information? Is it a quick way of doing things when it comes to carrying out the sample? It might be quick to come up with the numbers from the table, but is it actually quick to carry out, or is it convenient to carry out? So that's in terms of thinking about the disadvantages. Okay, right. So we've got exercise 5B there. There are 7 questions for you to have a go at. And next time round, we are dealing with bias. So we'll define what bias is. And actually, I think this one goes on quite a long time. It talks about surveys, handling errors, but also measures of central tendency. I think it talks about histograms as well. Dispersions, quartiles, and histograms. There's a ton of stuff in 5C. So enjoy this stuff while it is straightforward. Okay then, guys. Thanks for listening, and hope to see you back next time.